right, we ready to go?
You want to introduce me or what?
Yeah, I'm going to just say a few things. So thanks for coming to class today. I know it's a snowy day. We are really very lucky again to have another guest speaker, Larry Tesler, who has been in the industry for quite a long time, has agreed to talk to us, even though he's not really working on this area anymore, though unlike Dave, he's not really retired, I think. You're still working?
Still working.
Yep. Larry was at Xerox PARC in the early days and invented a bunch of the interaction techniques that we're all familiar with from text editing, like copy and paste. Then he went on to Apple, where he was part of the team that invented a lot of the interaction techniques in the Macintosh and Lisa that we're also really involved with. Larry's won a bunch of awards for this work, including the Lifetime Achievement Award for Practice from the CCI organization. And he's also been very influential in a lot of other areas, managing a bunch of people who've gone on to do really excellent things. So we're very lucky to have him here today. He's giving a version of the talk that he designed for the Lifetime Achievement Award a few years ago. And we'll also have plenty of time for questions. So if you think about what you want to know about the early days of PARC and the Macintosh. So let's welcome Larry.
Okay, great. Thank you. Okay, so I started in the computer field in 1960, and this was the user experience that I had. Big, I guess you sort of call it a mainframe computer, but it wasn't even a batch computer. It was one user at a time, so it was kind of personal. But you put a card deck into the card reader, and that's how you got your software and your data in there, and then it would punch cards out as to give you your answers. So it was a pretty crude system, and from the very first few weeks I was using this, I decided I really wanted to have my own computer that I could have in my house and have enough time to debug things without having to wait for card decks. So any place I went, I gravitated to opportunities to make personal computing happen. And weren't too many of those in the 60s. That really kind of picked up in the 70s, but in the 60s a little bit was going on in that direction. And there were mini computers, PDP-8, which was an early PDP-11, and a machine called the Link, L-I-N-C, that was acquired by Digital Equipment and really was designed as a one-person at a time computer. It had a screen of sorts, and used that around 1964 for doing some molecular diagrams as vector graphics. But in 1968, Doug Engelbart at SRI did an amazing demo called the Mother of All Demos. Hope you've heard of it. If you haven't had a chance, you should watch the YouTube of it. But it was a demonstration where he was in San Francisco at a computer conference, and remote microwave connection of his keyboard and mouse to his offices in Menlo Park, California, about 40 miles away, and a video feed. And this is what it looked like in Menlo Park. There was this kind of equipment, kind of primitive monitor that was adapted for use to kind of simulate what it would be like in the future when there were real good computer displays. People knew that would happen, but they had to kind of simulate them with $100,000 pieces of equipment at that time. And they also did this trick of superimposing Engelbart's image next to an image of what was on the screen, which at that time was an unheard of thing to do. And of course, now that's trivial. But in this particular case, what's going on is that he's describing a document, which is an outline, and these are the 7 headings, section headings in the outline. And these days, you would probably double-click on one of them to open, or click on a triangle or something, but things were pretty crude in those days, and you'd hit some keystroke that meant expand outline, and then you'd take the mouse and click one of those things, and that part of the outline would expand. And he did an hour demo or something like that, and then people in his group, participated, showing off particular pieces of software they had, and they had a lot of interesting, simple graphic software like org charts, and they had video conferencing, which they were actually demonstrating here to do the demo, and they had very rich hyperlinking between documents, which was again a new idea. They were just full of futuristic ideas, and one of the main ones, of course, was networking, and it was very early demonstration of kind of proto-internet stuff that again people had never seen, and the audience was very receptive. It was anybody in the field at that time knew that stuff like this was coming, but they were totally shocked to see that it was already here in at least the demo form. People envisioned this as being sometime in the far future, and most people hadn't thought at all about the details. And here, Engelbart had worked out the details and with the help of this guy Bill English, who was kind of their head engineer, they got the ideas running on this kind of primitive hardware. Okay, so jump forward a couple of years to 1970, and Xerox Corporation was worried about this kind of technology because people were predicting that it would obsolete paper, and that wouldn't be too good for Xerox. So they decided they better get ahead of the game and get into this field before other people did, and so they could transition their copying business into a computer printing business and actually sell the workstations as well, something kind of like what Engelbart was thinking about. And in fact, they hired people away from Engelbart, including Bill English, and he started a group which I joined in 1973. And he attracted a lot of people from SRI, where Engelbart's work was done, plus a lot from other places. Brad, are you still there? Am I talking to no one?
No. I'm actually off the camera, sorry.
Okay, if we do get disconnected for some reason, do you have my cell phone number?
Yep, I got it.
Great.
We're good.
So this is a building that Park opened in 1973. The first 3 years they were in temporary housing in the same neighborhood of the Stanford Industrial Park. And Park still exists today. They've dropped the Xerox from the name. It's now Park, a Xerox company. And they do work for other companies than just Xerox at this point. But in those days, it was maybe 100 people and grew to 200. A lot of those were in hardware kind of areas, obviously laser printers, but also advanced materials. They were looking at semiconductor displays and other things that were futuristic types of things. But there were 2 groups that were very software oriented, called the Computer Science Lab and the System Science Lab. And the name, excuse me, the names of the groups don't really tell you what they did or how they were different. They were mainly different to look kind of culturally. They had different leaders and sort of slightly different philosophies. But we worked together between the 2 labs on a lot of things, including the Alto, which was often known as the first personal computer. As I mentioned, there were things like the Link before that in some ways were personal, but they weren't designed to be used in this modern way that Engelbart had pointed the way to, while the Alto was very much designed to be able to do things like NLS, Engelbart's NLS. In both this picture, you can see there are two devices in Bill's hand. On the left, there's a 5-key corded key set that was like 5 piano white keys. And on the right, there was a 3-button mouse that was kind of clunky, as you can see, pretty large. There are mice made that large today, actually. But for most of the time, most of the mice are a lot smaller than that. Mice today tend to have 2 buttons, sometimes 1, rarely more, as primary tools. But you can obviously get mice today that have extra buttons. Engelbart really thought buttons on mice were excellent, and the story is he really wanted 20 of them or something. But this is all they could fit, so they made a 3-button mouse. Here I am in 1975, about when most of the work was finishing up that I'll be talking about. And just a sec. You can see it's a portrait screen, wasn't rotatable or anything. And there was, again, the 5-key key set next to my left hand, and not visible, there was a mouse. And again, at that point, it was a 3-button mouse. We didn't think we were necessarily going to have a 3-button mouse in a product, but it was something to experiment with. Excuse me. Okay. Mice. So the original SRI mouse was invented by Engelbart in '63, and that's shown in the upper left. It was a wooden mouse with a tiny button. By '68, and actually not a lot earlier than that, they had a 3-button mouse. And then at the bottom, you can see the 3-button mouse that mostly we used at Park. Sometimes Park experimented with mice where the buttons were rotated 90 degrees from that. There were other mice in the world, in particular in Germany, that apparently were independently invented, but slightly later. So in 1973, I arrived at Park, and I had come from Stanford AI Lab. At Stanford AI Lab, we tended to share an attitude that NLS was too complicated for most people. And several of us independently drew that conclusion after seeing it, largely because we were used to using a program called TV Edit and a descendant of that called E that had a rather different paradigm of user interface that we thought was more natural. And so we tried NLS, but we didn't really adopt it there. So when I got to Park, there was this kind of assumption that the user interface was probably going to be like NLS, but there was also some open-mindedness that if something better came up, they'd switch to that. While at SRI, they were pretty attached to the user interface they had, which I'll be showing you in a moment. But I had a little experience doing participatory design and running user studies from my early days at Stanford, and also from consulting that I did while I was a student and after I graduated for a few years. And I consulted for various clients doing applications, and even though they were often not even interactive in the early days, they were, with punch cards. With punch cards, you tended to come up with a language, and then people would put their application, describe their application problem in this language that was tied to that application, and then you'd get them punched on cards. And again, the language had to be pretty easy to write and not very error prone. And so I worked with a lot of users and on the machines with and without screens to figure out what worked for them, and develop some pretty easy to use software. So I had that background, which was
Can I interrupt?
at that point.
Question?
Yes.
So did that idea of doing user studies and participatory design come from psychology, or do you think you made it up?
Well, I never took a psychology class, so it didn't come from that. When I was a freshman, I was recruited to take over the programming of software that was developed by some older students, Larry Breed and Earl Bobert, developed something called the Stanford Cart Stunt Program that was used to prepare the animations for halftime cart stunts at football games. And that was used from about 1961 to 1970. And from 62 to 64, I was in charge of it. And when I first took it over, the language was difficult to use for one reason, just because it was all numbers. There were no mnemonics yet. And so Larry Breed, when he turned it over to me, said, unless you want to do all the programming yourself of every stunt, if you really want the student artists to do it, you better make this language easier to use. And I would start by using some mnemonics instead of just numbers. So that was the first thing I did, but I found that that wasn't enough. The students really just made a lot of mistakes. For example, they would leave out a coordinate in the long list of X and Y's for all the vertices of the graphic, and so I couldn't figure out what was going on. So I asked one of them whether I could sit with them one day while they coded a stunt and watch what they did, just on a hunch that I might see something wrong. And so I did that and saw right away that they were just sometimes forgetting a coordinate. They were confused about punctuation. They would misspell things. They didn't think that was important, and just they had some conceptual errors. So I watched them work and learned pretty quickly, just within the first hour, that I better not talk, and I better encourage them to talk instead, because that's the way I would find out. So this was just empirical and intuitive for me that this was something I should do to find out what the problem was. It worked very well, and I made some changes to the program. One that I remember was that since they would sometimes drop a coordinate, I made commas allowed. You could put commas after a Y and before the X of the next pair. So the program expected lots of numbers, and if a comma was there, it had to be after the Y and before the next X. If it saw something other than two numbers between the commas, then it knew something was wrong. So the commas are optional, but we encourage everybody to put them in, because that way they'd get error checking. And it would, abort the job and print out a message showing them, where the comma was missing, and they'd or where the coordinate was missing, and they'd add it and run it again. And then I gave, mainly a lot of it was just better error messages, more explanatory, using the text mnemonics and names of shapes and things like that. But then when I did work for other people, I did a similar thing where I would work with them and let them use the prototypes and see what mistakes they made. So that became my habit in the 70s. I didn't do it many times. I think I may have done it 4 times on projects, in the 60s, I mean. And between 61 and 68. And then after 68, I joined the Stanford AI Lab, and I was there till 73. And there we weren't building end-user applications, but I did learn a lot there about psychology, which I had not taken in college. But I worked for a psychiatrist at Stanford AI Lab, and people like Don Norman and Terry Winograd came to visit us from their places, and I learned a lot from hearing them talk with my boss, Dr. Colby. So yeah, no, I didn't learn it anywhere. I developed it on my own, and then wrote a paper about it in early 1980s, I guess. But it was already, by that time, becoming widespread as a technique. And it was something that was well known in, if I had taken a course in educational psychology, I would have learned it in that way. Should I continue?
Yes, thanks.
Okay. I'm going to turn down the volume for your stuff so it doesn't echo quite as much. All right, so one idea I had was to run a blank screen study. Again, this is one I just thought of. What if I just gave them a blank screen and pretend that there was text on it. Because I found that I ran a little study at Park, and they were evaluating what I was having them use, but I didn't know if we were exploring the full space. And at that point, I had this notion that some things were more intuitive than others. I wouldn't say that today without qualifying what I mean by that, but I really believed it literally in those days, and felt that for me to find out what was intuitive for them, I needed to watch what they would do when there was no predisposing bias, like software that was already developed and that they would be using. So I thought, well, what if there's just a blank screen? They could tell me what's on the screen. So I gave them a problem. I gave them a typewritten document that had markup all over it, you know, carets and cross-outs and little marginal insertions and things like that, and said, pretend that this screen could show you anything you wanted, including this document, and that you had a way to point at things at the screen, and that you had this keyboard, which was actually there, but no pointing device. And because the mouse was a controversial device at that point, I didn't want to bias them by having them even see that. Maybe they would prefer touch screens or light pens or, you know, RAND tablets, which were like today's touchpads, but with a stylus. And so I had a secretary sit down in front of the screen, and I think I may have run only one person one time on the blank screen. I might have done two, but I only have saved notes from one blank screen study. So that's the only one I'm sure I ran. But it was just very quick. And she had used word processors before, a couple different kinds though. So I felt that she would be biased by that, but not, but understands that anything would be possible. And what she did was not what was done in any of her existing, pre-existing experience. She took her finger to do, say, a deletion, and she pointed at the screen, and she said, okay, these are the words I want to delete. And then she ran her fingers across to the right, like she was crossing it out. And she was talking out loud, and so she said, I'm crossing it out now, and when I let go, I want it to go away. And then she thought about it some more and said, no, I don't want it to go away just that quickly. I wanted to show me what I was going to delete, and then press the delete key, because that way, if I make a mistake, it won't delete something I didn't mean to delete. So okay, so she would love a touch screen today, but in those days we couldn't do that quite yet with any decent quality devices. So I figured, okay, maybe we could use something like the mouse and or a touchpad and have her do that and see feedback on the screen. And then one thing as it says in the slide, is she wanted that what was on the paper would be what was on the screen. It would look exactly the same, line breaks in the exact same place, and just she would perform the editing steps. So one thing that was very important was that she had said first I would select, she didn't use that word, but I would point at what I want deleted, and then I would hit the delete key. So that means you would first specify the object and then the verb, which is the action to perform. So then I showed her and another secretary the NLS. We didn't actually have an NLS system, but one of the NLS developers who we'd hired re-implemented the text editor of NLS without the graphics and without the networking, and called that the research character generator editor, and because of the hardware it was using to generate characters, and so that we called that RCG. And in NLS, the syntax was the opposite of what the secretary had asked for. First you would say delete, and then you would point at what you wanted deleted. So let's take a look at that. That's the main subject of my talk today. So in both NLS and RCG, the way you did delete was you would hit a key to mean delete, and in fact you would hit the D key on the keyboard, or use the key set and press a D there. Well, there's only 5 keys on the key set, so you might wonder how it was used. It was a chorded key set, so like on a piano, you could press more than one key at a time. And so they numbered the keys 1, 2, 4, 8, 16 from right to left. And then if you press the 1 key and the 8 key, you get a 9. 9 is the I is the 9th letter of the alphabet, so that's how you would type an I. If you wanted a D, that's the 4th letter of the alphabet, you would type a 4, which was just the middle key. And so you would memorize the chords for the most common commands, and some people memorized the whole alphabet and could actually type. One guy could type 40 words a minute with one hand on the chorded key set. But this device worried me a lot because it didn't seem like something that would seem easy for people, and they would probably be frightened away from it. Sure enough, they didn't like it. But you didn't have to use it. So you could use the keyboard, and the secretaries I tested didn't want to use the key set. They preferred to hit the D key on the keyboard. Did the same thing. Okay, once you hit the D key on the keyboard, you went into delete mode. And so in delete mode, the first thing you would do is you'd specify, well, you had a chance to modify the command and say whether you're going to delete a character, a word, a statement, which was a paragraph really, or an arbitrary range of text, which was called just text. And you would decide which of those you wanted by typing C, W, S, or T. And T was the default, so you didn't have to do the T if you didn't want to, if you just wanted to do text, arbitrary text. Then you would go, you'd still be in delete mode, but now you might be in delete character, delete word, or delete statement mode. At that point, you would do what's called marking, which was taking the mouse and using the left button to click something. If you had already typed DC, you would now click a character. If you had typed DW, you'd click a word, anywhere in the word. And then if you wanted DS, you would click anywhere in the paragraph you wanted. If you wanted anything else, you would type D and then you'd click 2 places, the 2 ends of the selection, and it would, in any of those cases, it would highlight it. The highlighting was done at that time by underlining, and so it would underline all the characters or the word or whatever that you specified. Okay, now you've gone through 3 steps of the 4, and the 4th step you would confirm, because as the secretary had said, you can make mistakes. So you then had to say okay. So you could do that by hitting the enter key on the keyboard, or by clicking the command accept key, which was the 2nd key on the mouse. So this took between 4 and 5 actions. Really needed only 4 because you didn't have to type the T, but you either had to type CWS or 2 mouse clicks. And so this turned into 4 steps altogether. And the NLS people were in love with this interface. It was very general. You could have up to 26 different commands, and they generalized it later by having commands that were longer than 1 letter. Of course, you couldn't have one that started with DC, but you know there aren't any words that start with D and a W or an S, so they extended it so you could have lots of commands. But this wasn't considered too friendly to the secretaries. If you wanted to do a move, insert, or replace, you would just, instead of E, you type M or I or R, and then you would have an additional parameter: the place you want to move it, where you want to insert it, and what you'd like to replace, what it would be replaced by. So I can't remember what order they went in, and of course people always forgot that as well, so that was another problem with this interface. So when we ran the RCG user study, I took notes, and there were some notes in here, and they liked some things. They even liked the key set at first until they played with it a bit, and then they kind of soured on it and felt they wanted to keep their left hand on the keyboard, and they were having trouble remembering some of the chords that were not simple ones, just like A and D were simple. They liked the speed. They would forget to point. They'd forget to click. They got confused about what was append and what was insert, because they append put something after and insert put something before, etc. So they had a mixture of reactions. But one thing they kept asking is, which mouse button should I click? How many times should I hit Command Accept? If you made a mistake, you would hit the right-hand button, Command Delete, and that would take you back a step in this moded syntax. So if you did the mark and then you realized you had made a mistake on the mark, you'd hit Command Delete. If you'd done 2 marks, it would delete the second mark. If you hit Command Delete again, it would delete the first mark. Hit Command Delete again, it would undo the choice of noun, and so on. And this really got them confused. They had to either mentally keep track of what mode they were in, or where they were in the sequence, or remember to look at the bottom of the screen where it had a sort of syntax diagram and showing them where they were in this command structure. They considered it very ponderous, and so compared to the typewriter, they didn't see it as an advance. But they also saw how powerful it was, and they loved that it did things like automatic word wrapping, and that once they learned it, or if they remembered it properly, they could move arbitrary things from one place to another very quickly, very easily. And they liked that. Okay, so we drew some conclusions from this, which was they kept getting confused about what mode they were in, what key to press, and so on. And one of the issues was that the character keys on the keyboard had a double purpose. They were used to specify a command, and they were used to enter a character into the text. So I concluded from that having any kind of command mode was a bad idea. Typing characters should always put the characters at a location where there's a cursor, and it should not ever issue a command or name a command. Second thing is that the mouse should just be used to point at things. Having Command Accept and Command Delete was confusing to people, because one button would actually do things like that involved pointing, and the other buttons had nothing to do with where the arrow was on the screen, and that confused people. We should show people where the next character they type will appear. That wasn't the case in NLS, and that people sometimes would want to not take their hands off the keyboard to move the cursor, and there should be arrow keys or other navigation keys on the keyboard that would be a supplement to the mouse. All these things have endured into modern times on desktop computers and laptops that have mice. These I'm sorry. These are the conclusions we abandoned. Invisible characters confused the secretaries, and we thought carriage return should be a command next paragraph and not a character. It turned out that we abandoned that later because, first of all, they got used to the idea of spaces and carriage returns being characters and liked the idea that you could delete them. It just surprised them in a 30-minute user study. But once they would use it for a few hours, it made a lot of sense to them, and they wanted the functionality. Also, people got the idea of turning on invisible characters so you could see them, and as a learning device especially, or when people get confused, they'll turn those on. Same thing with spacebar and carriage return. We thought those should be commands, And we actually built an editor where they were commands, but even then, the secretaries really wanted them to be characters, and so we abandoned that idea. So one thing I learned there was that sometimes when you learn things in a user study, you're learning something about the first few minutes of an experience, and it may not portend the rest of the experience. If it's a website, in my opinion, just jumping to the future, if it's a website, you don't want a bad experience or a confusing experience even for 3 keystrokes, because they can just close the window and go to some other website and you lost them. But if it's an application that they're going to be using every day in their job, it's okay if there's a little confusion at the beginning, as long as there's help, text, prompts, other people to teach you, or just something where trial and error usually ends up with a happy outcome. And this was a business piece of software, so it was okay. We concluded that they might have to start understanding what it meant to insert or delete an invisible character. And the last conclusion we had was that we should first use the navigation keys on the keyboard and then teach them the mouse as an accelerator. And we tried that for a while, actually, and it was actually a good thing at that time. But after a while, we realized the problem was that our mice were pretty terrible. They were extremely inaccurate, and when you pressed the button, the mouse would move and select a different character than you wanted to. You couldn't aim very precisely. The mouse was clunky. The cord would be sometimes too stiff or too loose, and you'd run over it with the mouse or would move the mouse when you let go of it. There were just a lot of things about mice that took until 1980 to fix. So this was 1973. So that was mostly just mouse hardware problems. Okay, but we had, this was something I tried. The key set, it seems to me, was a good substitute for function keys. There were function keys on word processor keyboards in those days. There were only a couple of word processors in the market, but they had function keys. And the Alto keyboard had virtually no function keys. And that was something that people felt that we should try to find a way to do without. And that was a good idea, but I wanted a few, so I experimented with putting insert, delete, move, copy, and undo on this 5-key set, and what that would be like, and tried that on people. Oh, and then the mouse, I was going to name the buttons, name the keys dot, dash, and damn it, and do something like have the dot select a character, the dash select a word, and the damn it do a command delete or something, or an undo. These didn't go anywhere. Then I did something. I joined Park in February '73, so I started running these user tests in April, and then by June I was starting to get some ideas about how to do that. And I had thought a few years before that, when working on a magazine, that doing cut and paste, that there ought to be a cut command and a paste command and then a page layout program. So this was the time, June '73, where I started thinking about, well, maybe we could use cut and paste for text editing too, not just page layout. But it would be funny. It would be, an odd-shaped thing that you would cut out and paste up in page layout goes into a blank area on the page. There's not necessarily a blank area when you paste in text. So, and you can see the notes I took here was trying to come up with some kind of compromise. But then I remembered that I had seen a demo of a version of TV Edit at Stanford done by Pentti Kanerva, where he had a 2-step move. You would select text, you would move it to a buffer, then you would select some place in the document and say restore buffer. And that could be used both for undoing the cut if you didn't move the selection, and for moving text if you moved the selection in between. And the other thing that was very cool, was in between the cut and the paste, you could do other things. And I thought that was key because I was always trying to figure out a way to get rid of modes. And this would be a great way to get rid of a move or copy mode. So, cut and paste. So I started talking that up with people, and they said, oh, you know cut and paste because you worked in a magazine. Most people never heard of cut and paste. It wouldn't be a familiar metaphor to use at all. Also, what would happen if you cut and then you meant to paste, but you went doing other things and then completely forgot? You might cut something else, and then you'd lose that thing that you meant to paste. It's going to be 4, 5, 6 steps to select something, then cut it, select something else, and then paste it. And that's going to be slower than NLS, where you don't have to do 2 commands, you just do 1 command, basically a move command. And maybe it'll work for text editing, but it's not going to work for graphics like painting. And so how do we know that that is going to work? Well, move and copy are very general, and they would work for anything. So I had to respond to these objections, and ultimately I mostly responded sometimes by showing it wasn't true, but also focusing on the advantages. There won't be mode errors, and then some early experiments by Tom Moran, which he extended 8 years later and published a paper with Terry Roberts about, actually showed that Gypsy, the text editor that I built in 74, 75 with Tim Mott, based on this research, actually was faster than NLS. Experienced Gypsy user could perform a task in about 2/3 the time of an experienced NLS user. And the reason was that, in fact, fewer key presses and button presses were required on average. And Tom Moran had been developing with Stu Card the keystroke model of predicting times to execute interactions in a user interface. So that was going on. He actually joined Park just as we started implementing Gypsy in 74. So I won't go through these numbers, but if you go to the very bottom, you can see that on the bottom left that Gypsy has the smallest time per task, and also in the second column, the lowest error rate. And then, because it was modeless, you could do other things between cut and paste. And even though, yes, you might forget to paste, we would have an undo, but also you could open a different document, paste in a different document. You could scroll and then paste someplace else, and you couldn't do that in NLS. You use the outline feature to try to get both things on the screen at the same time, or you would split the screen into 2 windows and get two things on the screen at the same time, and then you could do your command. While in Gypsy, you could start your move right away. You wouldn't have to go find the place you're going to paste before you can cut. And that was especially important going between documents. So I was advocating that we get rid of modes. And here's the definition of a mode: state of the UI that lasts for a period of time, not associated with any particular object, has no role other than to place an interpretation on operator input. You don't really need the mode. And you have to keep track in your head of what mode you're in, or you need some area of the screen reserved to give you feedback about what mode you're in, and you have to remember to look at it when you get confused. The other thing that I talked about a lot, I had previously at the AI lab worked on natural language parsing and generation, and because of that, and also I worked on compilers, and because of that I was very focused on syntax. And these days we don't talk too much about the syntax of commands in user interfaces, but in those days we were all computer scientists, so that we talked a lot about syntaxes and grammars. And one of the important things in programming languages were the difference between prefix syntax and suffix syntax. If you are familiar with programming language syntax, things like Polish notation and the language forth uses suffix syntax, and most higher level languages use a prefix syntax. And that's what programmers are used to, mostly prefix syntax. And so programmers tended to write text editors for themselves using prefix commands where the verb came first. People who designed word processors who had users use their software who were not technical people more often came up with a suffix syntax where you select something first and then you give the command key. And usually it was done by having a whole bunch of function keys on the keyboard. Delete character, delete word, delete paragraph, delete line, you know, many keys. Or sometimes they would have, you know, a word that would select the word around the cursor and then a delete key. That was less common. The problem with the prefix I found was that the editor had to enter a mode because the verb could not be executed yet. When you said delete, the software had no idea what you wanted to delete, and it just kind of had to wait. And then when you were done selecting it, because you could make errors, you'd have to do a confirmation. Well, in suffix syntax, you would select something. If you made a selection error, you would just select again. You could select 100 times in a row and nothing would happen except it would show you the feedback for what's selected. When you finally got the right thing selected, you would hit the key for the verb, delete or whatever. Now you still could make a mistake, and so we added the undo command, which was something we borrowed from interlisp, which was Warren Titleman's shell for a Lisp that he implemented that we tended to use at Park for certain kinds of prototypes. Okay, so I felt that modes degraded usability, both from having experienced modes a lot and by watching other people, especially when... Hello?
Yeah, so that basically assumes that selection is problematic and selecting the command is almost always not problematic.
Good point. The mice in those days were just terrible compared to today. And so people made a lot of errors. But even today, people make a lot of selection errors. And in Photoshop, in fact, it's a little different. In Photoshop, it is often very difficult to make a selection. You'll select a polygon, you know, lots and lots of clicks. Or you will carefully try to highlight something to pixel perfect, you know, resolution. And if you miss by, or you'll extend a selection, that's the more common one. You'll add another area to a selected area, or you'll subtract a selected area from another selected area. And then if you make a mistake, you have to go back and do it all over again. So in their case, instead of undoing that entire selection process, because it can require so many steps, undoes just the very last part of it, which is back to the way it was in NLS. So in a program like Photoshop, it's even more important that, you know, that to recognize that selection is harder. But if selection is that hard, Photoshop goes even further and makes you undo, or lets you undo, an individual piece of each selection operation. These days, it's probably less of an issue with a mouse, but with touch screens now, which is what most people use, there are a lot of mistakes if you're selecting text. And it's very hard to extend selections. It's very hard to auto-scroll text while you're selecting it. It's very difficult. And yet, undo is often omitted from applications on touch screens. But fortunately, most of the time when there's text editing, undo is offered, at least in iOS, which is the one I'm most familiar with. Does that answer your question?
Yeah, thanks.
Okay, so why are modes bad? These are the things we observed. Keeping track of mode changes distracts a user from the task at hand. There was a professional writer who I gave Gypsy to one day, which was the day before he left Park after the contract he did. He said, I heard you had a different editor than the one I was using. Could I try it? And so I gave it to him, came back the next day, found a note on my desk saying I was up all night using this editor. This is the first time I was able to just to write what was in my head and not be focused on the commands I had to give the computer. And it just felt much more natural to click and drag through text, which was something I had there that hadn't been done before. Again, because mice were inaccurate, and instead you would click one spot, then you'd click the other spot, and that would extend the selection. People didn't think it was possible to make, or programmers didn't think it was possible to make drag through accurate, because you'd make an error at the beginning of the selection and you'd make an error at the end of the selection. I came up with some tricks that reduced the error significantly, but mainly it just didn't matter if you made a mistake. If you drag through and make a mistake, just drag through again and do it 2 or 3 times till you get it right, and then give your command. Well, that in NLS, it was something you had to undo if you made a mistake. So this was something that people found freeing. If the current mode is misjudged, it could cause disasters. There's a classic thing in Bravo, which was the editor at Park just before Gypsy. And we built Gypsy on Bravo just by changing its user interface. E was select all, selected the entire document. D deleted whatever was selected. I entered insert mode, and then T in insert mode just typed a T. So if you typed the word edit thinking you were in insert mode, but you were actually in command mode, it would select the whole document and delete it and insert a T, so undo no longer worked, because we had a one-step undo. So you had to be pretty careful. You type the word edit to make sure you were in edit mode, typing mode. So people realized pretty quickly that modes were bad. The other thing was people would always say, how do I get out of this mode? And they felt stuck and sometimes didn't know what to do. And there had to be a consistent mode escape, and some programs didn't have one. So we built Gypsy, Tim Mott and I. Tim spent some time, I spent a little time, but mainly Tim spent time at Ginn & Company, which was a publisher that Xerox had acquired that wanted us to build a manuscript editing system for them and then a page layout system. And they liked the idea of cut and paste because they were publishing people. So we were allowed to try using it in the text editor even, not just the layout program. And we did the text editor first. And after a little design work with them, kind of participatory design with a few visits both directions, we came up with this screen layout, which was a document in the middle. When you cut something, it was going to put it in the wastebasket, which was our name for what's called a clipboard now. And then there was a little command window that was kind of like a menu bar with one menu. And when we did this diagram, there was a file command, and you click the word file and it would save your document. There was a cancel command, and that would ask you if you really want to cancel, and basically it was a revert. There was a scan command, which was what the secretaries thought was a better word for search or find, but it was basically find box. And later we added substitute, which was like a replace command, and it had replace blank by blank. And you would take the mouse and you'd click between those two curly braces, and you would type, and you could not only type, you could edit whatever you typed using click, drag, select, copy, cut, paste, whatever you wanted to do. You could edit the search key. There was no editor before that I know of where you could edit the search key. You would type an F or an S or something, then you would be in find mode and you'd type the search key. If you made a mistake, you'd have the backspace to the mistake and type forward again. and then you'd hit enter or something to initiate the find. I'm not sure it hadn't occurred to anybody, but we wanted to have no modes. So that meant you couldn't have a mode for entering the search key either. And you had to be able to edit the search key. And while you're editing the search key, you needed to be allowed to go back in the document and edit it some more, and the search key would just sit there. It was not a mode. We didn't even have modeless dialog boxes. No modes at all. So we're pretty religious about it. So those two were kind of innovative things. This is a screenshot from a video. That's why it's a little fuzzy. But you can see here that my cursor doesn't work here. But in the upper left, there's a scan for. Then there's an all for select all. Substitute, command, file, cancel. And there was also a command called length that the publishers wanted to tell them the length of their document. Because word counts were very important for in publishing. So here's a case where somebody selected a paragraph using either, it might have been a click in the margin, it might have been a click drag or double click drag, or I'm not sure how they selected it. And then the keyboard at this point had evolved, and this shows a mouse next to a key set, which wasn't really the way it was done. But the right-hand key was cut, the left-hand key was paste. The keys adjacent to them did scrolling. We did not have scroll bars. We did have the equivalent of the thumb or elevator in the scroll bar. That was done on the screen. But there were no arrows on the screen, and that was largely a limitation of, we used a mode in the Alta that was text only, where there was no graphics. And the only graphic we had was this horizontal line that we were allowed to have dark lines separating different parts of the screen, but you couldn't have icons or graphics at the same time as you had the kind of text mode we were in this hardware. And then the middle key was a modifying key that accelerated the scrolls and changed a cut to a copy, a shift cut basically was a copy. And also, if you hit cut and paste at the same time as a chord, it exchanged two selections. So we had a way to make a second selection, and the exchange command would exchange those two passages of text, which is a very common operation in computer programming, and I recommend it for computer programming. The editors thought that happened occasionally, but not in textbooks. Journalists might find it useful, but they didn't think it would be that useful for textbook editing. So we dropped it pretty quickly. So let's compare syntax. In the modeless syntax that we use in Gypsy, you would first use click or click and drag or double click or click in the margin or whatever to select something. And then you would specify the verb, cut, paste, or boldface, or change line spacing, or whatever the command was. Or you would type, and if you had clicked an insertion point, then the typing would go in between the characters. And if you had selected something that was not just a zero width, but some one or more characters, then it would replace what was selected. And that was not, there was nothing else in the world that worked just like that. And yet today that's still the way mouse-driven interfaces work. After, what is it, 40 years. And in NLS, which was a heavily moded system, and by the way, I just have to tell you again, once again, NLS was an unbelievably futuristic system. I have no complaints about it, except that it used prefix syntax and was heavily moded. And you would have the verb first, delete, move, insert, replace, as I showed you before. And you would have, now when you look at it this way, you go, that is kind of fewer steps, isn't it? And if you enumerate all the different cases, it turns out that in almost every case, the modeless way to do it requires fewer key and mouse strokes, and never has to be in a mode. Now, if you make an error in selection, as I said before, you can reselect. If you make the wrong command choice, you undo, and it'll undo the action that you just did. And in NLS, the backspace, oh, I forgot. When I said there was Command Delete, I made an error. There was a backspace key, and there was a Command Delete key. And in fact, the mouse buttons, I believe, were actually, the left button was the main button, which was select, also Command Accept. The middle button was this backspace, and the right button was Command Delete. I'm 90% sure of that. I might be wrong. So you used one key to back up a step, and if you wanted to really kill the whole command, you hit the Command Delete key. So it was, the backspace was the thing you would do repeatedly. Okay, we had a one-button subset in Gypsy, which was the top button only, or the left button, which was the insert between characters, click and drag, click in the margin to get paragraphs. Typing, cut and paste were about like today, and basically Command B, I, and U did bold, italic, and underline. But we didn't have a key called Command or Control. We had a Control key, but we took a little sticker and put the word look over it because we thought look was a more intuitive thing for the editors. The power users, we used middle and bottom buttons. Single click would select a character because it was hard, even with our mice, to select a single character by dragging it through it. Clicking in the margin selected a paragraph. I think clicking in the margin was, with the left button, was only there for drags. And double click or double click and drag selected a word or multiple words. That was Tim Mott's idea. We tried it on the main button, but a lot of programmers objected that double click was a bad idea and we should really not have it. So we moved it to this optional advanced user button. And the reason they objected to double click was because what happens if you move the mouse between the first and second click? How far a move does it mean? Or how much time between the clicks? Is it a time-based or is it distance-based? In either case, people are going to make mistakes. It's a terrible idea. And so they really scared us, so we moved it to that key. But we had this other feature, as I said, in order to do exchanges, you could use the bottom button to select the source, the top or middle button to select the target, and then you could do exchanges. And this was one thing where if you had two things selected, then paste changed its meaning. Instead of pasting the wastebasket to the selection, it would copy the source to the target. The number of people who ever used this user interface for power users was 0. This is a summary, you don't have to read it, but of all the different commands in Gypsy and which ones with the green checks are still the way we do it today, and the orange X's have been abandoned, and when both the check and the X are there, it's partly there, partly different. Dan Ingalls was across the hall from us implementing Smalltalk 76, and he had menus on the screen, but the menus were visible all the time, in a pane, basically. And so when he saw what we did, he went, oh, that's better. And so he took his 3 buttons and he made the first button be select, and then the second and third buttons would bring up contextual menus. And they weren't the very first contextual menus. William Newman had done graphical contextual menus before that for a graphics program. But Dan did contextual menus that looked like this, a column of commands. And if it was a window menu, it was close, new, print, things like that. And if it was the edit menu, the middle button, it brought up copy, cut, paste, undo. And I think select all and other things got added later. But this is more like the way we do things today than Gypsy was even, because we were using that key set. We didn't have function keys, and didn't occur to us to have pop-up menus for this purpose. That was Dan's idea. And so from there is really where today's interfaces came from. 1975, when we released Gypsy, coincidentally, Business Week heard about Park and got permission to come get a tour of it. And we gave them some demos, and in that demo, as you can see in the enlargements here, there was some talk of cut and paste, and there was some talk of Gypsy. Ironically, the cut and paste was not the cut and paste in Gypsy, it was cut and paste in something called Woodstock, which Dan Swinehart had implemented. However, he was involved in the Gypsy project, working very closely with Tim and I, giving us lots of ideas and advice, and he implemented cut and paste shortly after we proved that it was a good idea. He always thought it would probably be a good idea. I moved to Apple in 1980 and worked on the Lisa. I managed the user interface design, and that's where we came up with the edit menu, which unfortunately I don't have a picture of, but and also the clipboard as instead of the wastebasket, because wastebasket we wanted to use for the trash can, which as you see is a little bit to the left of that on the screen. Well, from Gypsy, Woodstock and Smalltalk were the first to adopt cut and paste and modelessness. There was a version of Bravo that was developed a few years later called Bravo X that was mostly modeless instead of mostly moded, and it had cut and paste. But I think it also had a move command that was a little different from the one in NLS. And from there, from Bravo X and Smalltalk inspired Apple's Lisa Write word processor, and Bravo X inspired Microsoft Word. And then, the Lisa UI got pretty much co-opted by the Mac. And the Microsoft Word and the Mac interfaces went to Windows. But Windows already had cut and paste from Microsoft Word, and that came from Bravo X. So that was the evolution over the period from 1975 to 1985, basically. And 15 years later or so, amazingly to me, when touchscreens became popular, and I had worked on the Newton, so I knew about touchscreens. We'd used a pen, had to use a pen in those days. I assumed that cut and paste would go away and the whole editing paradigm would change. But after experimenting with a lot of other things, I guess Apple decided cut and paste was still the way to do it, and drag through select, and select sort of like a double click, a select, double tap to select a word. Some of those things carried over, amazingly to me, and are still being used today. So this, in summary, is the text editing pattern that was introduced in Gypsy. Click to select an insertion point, double click to select a word, click and drag to select a passage. All those were new. Type to replace the selection by new text. That was, I think that was precedented, but not unprecedented, but it wasn't common. Cut to move the selection to a buffer. Penty Canerva had done that in TV Edit. Paste to replace the selection by the buffer. Again, Penty had done that also. Control B to bold the selection, I and U and so on. Well, nobody had bitmap displays before that, before the Alto really, so they didn't need to bold or italicize things yet. They didn't have a way to represent it. Maybe underline could have been done that way, but and it probably was. There was probably an underline key. Undo, which Warren Titleman had done in Interlisp, and edit your search query. All these things were introduced in Gypsy, 1975. Summary: qualitative and quantitative user studies showed that a two-step cut and paste enabled faster editing and fewer errors. And that study, as well as just history, have validated the usability advantages of modeless text editing. Now notice that I keep saying modeless text editing. I don't say modeless user interfaces. Some user interfaces are best not be modeless, best off being moded. And mostly that's, for example, any kind of painting program has situations where you want to just choose colors and shapes and tools and so on before you start working with your pointing device. That doesn't mean that everything has to have a mode, and there can't be any postfix, but there are situations. Luckily, when you're doing graphics, you have to be looking at the screen, because when you're moving that pointing device. So the worst mode errors are in text editing, when you might be transcribing something, looking at the screen, looking away from the screen, talking to somebody while you're typing. And that's why I only insist that modes are bad in text editing. There are cases where modes are not a bad thing outside text editing. And that's the end of my presentation. Do we have we used the time up, I'm afraid, or are there a few more minutes?
We have about 6 minutes.
Okay.
Anybody have questions about? I would, if you have a second, maybe talk a little bit about some of the designs in the Lisa and Mac that you influenced. Did you make any of those design decisions, or were they made by others, or?
Right. I managed the Lisa user interface development. Since we had a license to Smalltalk, we were able to, and Smalltalk was public information. We had been given the demo. I gave the demo. Dan Ingalls and I gave the demo to Steve Jobs back in 1979. So, of course, we were not only familiar with Smalltalk, we were allowed to use ideas from that. And so that's all the cut, paste, copy was taken directly from there, and undo and double click and all that stuff. But other things that were innovations that I contributed to were the pull down menu. I helped Bill Atkinson come up with that. In applications like Excel and Word, there in the scroll bar there's a split icon that you can drag and split your window into panes. Engelbart had actually come up with that, but he did that in a moded way. I came up with the idea of having that little icon in the scroll bar, at the end of the scroll bar, that you would drag. But mostly, I ran a lot of usability studies and made recommendations about changes to designs that the programmers had come up with. We had literally 1,000 applicants per job at Apple in those days in engineering, and we chose the very few people who convinced us during the interview that they had very good instincts for usability, and they talked about, when we asked how they decided what was better, they started talking about how they showed this to their next door neighbor, and they blah, 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 and we went, okay, you got it. So mostly I was doing management. Let's see, there were dialog boxes that Rod Perkins, the programmers know they needed it, and convinced me that it was okay to have a mode in that situation because it was dangerous for the user to proceed without acknowledging that there was an error.
Do you think, so we had Dave Smith here Monday, and he said that he invented those as property sheets on the star.
Yes, property sheets on the star were, I would say, similar. I would also say they're different in several ways. First of all, the situations that you use them were mostly different. There was only one situation, and I think it was called the print command on star, where there was a dialog box that came up, but all the widgets in the dialog box were different, and then they mostly used it as a property sheet. It was like the get info dialog about an object. You select an object and hit a properties key, and it would be like get info on the Mac today or properties on Windows. And so the Lisa engineers independently came up with the fact that they would need a dialog box to supply additional parameters. And Rod Perkins came up with the radio buttons and checkboxes the way they are, more like they are today. The Mac made them even more like they are today. the thing I added was the alert box, which was the modal box that gave you an error and offered you choices of proceeding and canceling and so on.
What about the grayed out items and menus? Was that original to them?
Oh, grayed out items. That was done in a brainstorming on the Lisa project, and I may have come up with the idea. It might have been Bill Atkinson. It might have been somebody else. I'm not sure. The shortcut keys, again, that was, I think Bill Atkinson probably came up with that one. Let's see. Oh, scroll bars on the right bottom were on the Xerox Star, and on the Smalltalk they were only on the right side, vertical scrolling only. And so on the Lisa, it was just obvious that we needed horizontal scrolling to do a spreadsheet. So people came up with that without much thought on the Lisa spreadsheet. The little elevator that goes up and down was Ted Keller's in Smalltalk at Xerox.
I guess it was, the other big one was one button.
Dragging windows around by the title bar, enlarging windows with the lower right-hand corner. Those were invented by Bill Atkinson.
Sure.
What'd you just ask?
Having a one-button mouse instead of two?
Oh, the one-button mouse. Well, of course, it turns out if you remember that diagram of the mice, the very first the very first Engelbart mouse was one button, but he wanted 20 of them, and they compromised on 3. So in Gypsy, we had the one-button subset that we defined, and in fact, that was all that anybody ever used, except maybe the middle button double-click to select a word. And so when I ran my very first user test with the mouse, in addition to what modem I in, the other big question was what button should I hit? And so I really wanted to get rid of the other buttons. And it just took a while to figure out how to have just one button. That was, we finally figured it out in '75. But we didn't even really do it, because the mouse that we had 3 buttons, and we weren't allowed to change that. So I asked for 1-button mice and 2-button mice, and they finally did do 2-button mice, because that's what the Star concluded they should have. But we didn't get 1-button mice till Apple. And then at Apple, I wrote a memo with the help of Jeff Raskin and Bill Atkinson, why we should have a 1-button mouse. And product marketing manager Trip Hawkins liked it, and Steve Jobs liked it, so we did that. And by the way, if people say, well, is it really better than 2? Tom Malloy, who was the head of the Lisa Wright project, was an advocate of 2-button mice, 1 button to click on a location and another button to extend the selection, because you couldn't always click and drag on a very long, selection. And so it was almost a toss-up, but we took our stands, and I went for 1, he went for 2. About 15 years later, we're still friends, but about 15 years later, he said, Larry, you were right. 1-button mouse was the right thing to do. I said, no, Tom, you were right. Should have been a 2-button mouse. And the reasoning was, but we really both agreed, which was, in those days, no one had ever used a mouse. 5-year-olds didn't use mice, and it was a new gadget. It was inaccurate, and even the one we did at Apple was still not as accurate as the ones we have today. So it was awkward to use, and we had to convince people to use it, and it had to be super friendly and learnable in 1 minute. And we actually came up with a way to teach people error-free mousing in 1 minute, which we couldn't have done if we'd had more than 1 mouse button. But nowadays, people need the computer so much that they'll learn a new pointing device, or they'll even learn, double tap drag with, gestures on a clunky touch screen. So it's very different today.
I'm afraid we have to stop. There's another class trying to come in, but thanks again. Let's thank Larry.
Okay.